Everyone, welcome to Data Engineers number 71. We'll give everyone a couple more minutes to file in. While we're waiting here, don't forget to like and subscribe and turn on that notification bell. That way we can notify everyone when we go live and every time we post. Hey everyone, welcome to Cassandra Lunch. We'll give everyone another minute or so to file in, or Data Engineers, apologies. Don't forget to like and subscribe and turn on notification bells, so that way you get notified every time we go live and every time we post a new video. Alrighty, let's go ahead and cut the music. Let's start the video. Oop. All righty. Hello, everyone. Welcome to Data Engineers Lunch, number 71. Today's talk is going to be on tools for cloud data engineering, the summer 22 update. Today's talk is going to be given by Rahul Singh, who's the CEO and architect here at Anant. Co-organizers for this event are Rahul and myself. We need help finding guest speakers as well as sponsors. So if you're interested in giving a talk here at Data Engineers Lunch or our sister launch, Cassandra.Link, feel free to reach out to me. My email is listed below. We are a part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, sexual orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. We fall under Data Wranglers DC. We also have our sister lunch, Cassandra Lunch. You can find out more about all these various organizations and events that are hosted under the umbrella of Data Community DC at datacommunitydc.org. So what do we cover here at Data Engineers Lunch? We cover everything that is is data engineering, from the ingress to egress of data, whether that be data wrangling, ETL, reverse ETL, feature engineering, etc., as well as databases, and various other tools that we'll be talking about today. If you're new here, say hi, hello in the YouTube chat. Don't forget to like and subscribe and turn on notification bells. That way you get notified every time we do go live. Group roles, if you have a question, please ask it. We are monitoring the YouTube chat, so feel free to drop it in the chat. This is meant to be community, so please do share what you know with us. Feel free to drop any comments as mentioned in the chat as well. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life for us here at Anant. DataStax is a partner and a sponsor. GW University helps provide venue space when we have in-person events. We also have some organizational and institutional sponsors. If anyone has any meetups, hackathons, conferences, or classes they would like to promote, feel free to drop them in the YouTube chat, as well as if you're looking for a job or offering any jobs, feel free to drop those in the chat as well. Anant is hiring full-time or part-time positions, data platform operators, engineers, or architects. You can find out more at careers.anant.us. Currently, these events happen every Monday at noon Eastern. We are looking at having a more variable time slot, as well as our sister lunch, Cassandra Lunch, which happens on Thursdays at noon Eastern currently. Again, those happen, we are looking at a more variable time slot so we can cater to a worldwide audience in a live format. You can find out more of our events on anant.us/events. So we've also released our new runbook, Apache Cassandra Runbook 6. So let me go ahead and open this up. You can find out more. This is your last day to get it live. We are releasing our 7th runbook in a couple days, so feel free to get it. But this link is already in the YouTube chat, but I'll go ahead and drop it again. And so feel free to fill out the form. You get it for free. But again, you only have a day and an hour left. So once the day and the hour are up, runbook 6 will be gone and runbook 7 will be available. So get it while you can. And with that, we'll go ahead and hand it over to our guest speaker for today, Rahul Singh.
Hey, thanks, Arpan, for getting us started. Sorry, I didn't realize I was on mute. Yeah, those run books, you guys are making them scarce after what? How many days do you keep them out there for? I think you're on mute.
Yeah, sorry, I got lost in the screens. We put them out for about 2 weeks. So every 2 weeks, we release a new one.
Cool. Awesome. Very cool. Yeah, today I'll be giving a refresher on data engineering tools. We did this talk earlier this year, and in the last, well, it's now definitely been more than 6 months. So I was going to say, you know, I would have considered that as the winter of 2021 or the winter of 2022, whichever way you look at it. And in the last 6 to 8 months, have learned as a company and as an individual of cool things that I would say, you know, are warranted to take a look at it and just really go back and say, this is now something everybody should know, right? Because a lot of stuff comes in technology, comes and goes, and you wonder, should I really spend time on it? And the last time I gave this talk, I mentioned certain tools and I said, why am I recommending this tool? Why does it have any staying power? And that's why I actually added another section today. So I'm excited about giving an update to this talk. And it looks like I'll probably give an update to this every 6 months or so, because that's just the reality of our industry that we're in. And let me know if you can see full screen. There we go.
Yep.
Great. To the most popular tools in use today across 11 skill sets. Last time I gave it, it was only 10 skill sets, and maybe by next year we'll have more. Just a little bit about myself and our company. We help platform owners reach beyond their potential to serve a global customer base that demands everything right now. That's why you'll notice we talk a lot about real-time technologies. We design with our playbook, we build with our framework, and manage platforms with our approach so that our clients can think and grow big. Some of the people that we've helped succeed, you may have heard of some of them. And what do we do here? We're architects, and an architect is a chief builder. And the verb architect is to design or make, especially in computing. So we have a cool t-shirt, which I'm going to show you at the very end. If you're interested, you drop us a line and we'll see if you're an architect, and we'll send you an architect t-shirt. So distributed real-time components, generally this is where we play with for our clients and for our own, professional development and learning. The world has changed in data engineering from very batch-oriented to including batch plus real-time, and this is where we tend to work in. However, every platform has different components. It's not just distributed real-time components, it has other components. And so we have to know data engineering across different disciplines. The landscape of data engineering, this is, by the way, nowhere close to how many tools that are out there. In fact, this is probably a very, very simplified version of the different skill sets that are required in data engineering. But in our day-to-day, we come across these and tend to categorize tools into different buckets, although some of the tools that you see definitely can fall into many different buckets. So we're saying, when we say, hey, this is in the SQL bucket, it's primarily in the SQL bucket, because you can put JSON in Postgres, you can put XML in a SQL Server and in Oracle, and that's technically no SQL. But primarily, those tools fit into SQL. So same thing with some of the stuff that you have, in the ETL, reverse ETL. Earlier, I had put, for example, Stitch and Fivetran under data engineering, and I look at that as a mistake, because technically, everything from high overview, top level overview is data engineering. I also renamed data ops to orchestration, because technically a lot of these things do data ops. So this is a work in progress. And as I mentioned just 30 seconds ago, some of these things will fit into other buckets. But I want to look at them as, what is the primary thing that differentiates this tool, and why is it in this bucket? And why should you think about these buckets at all, right? What's the big deal? If you take a look at this, we're looking at the sources generally of data on the left side. And that's generally, that's, again, overall, people think about data engineering as getting data into one system, like a data warehouse or a data lake, and then clean it up, land it in a data lake, and then clean it up and put it into a data warehouse, and then do queries on it. Well, there's one new section that we're going to talk about today, which is the reverse ETL, right? It's beyond ETL, it's the reverse ETL. What does that mean? And what does that right side of that look like? Maybe in the next version of this, I'll have, the right side of this diagram, which is getting data back to the source systems. SQL, it's not, I don't think it's going to go away. In fact, we work with a database called Cassandra, and there's several Cassandra-like databases, and they use a variant of SQL. In Hive and Spark, we use SQL as well. DBT uses SQL. So SQL as a language, it just seems to fit the bill in terms of querying information and retrieving it, massaging it, right? It has a lot of functions built in. But in addition to SQL as a language, there are SQL relational databases, which people will say, oh, this is an SQL database. And these databases are relevant not only because themselves, like MySQL and Postgres, right? They're very popular. Different databases that are getting distributed, for example, they use these protocols. So for example, TIDB is a distributed database based on the Google Spanner white paper. It's a distributed SQL database. It actually uses MySQL variant for query. Or CockroachDB and Yugabyte's SQL layer, they use Postgres's variant of SQL. Microsoft's SQL, which is TSQL, it came from Sybase. People don't want to necessarily migrate from TSQL. Well, there's a thing called Babelfish that runs on top of Postgres to make it compliant with TSQL. And Oracle, a lot of people want to move away from Oracle to use things like Postgres or let's say Cassandra for different data stores. It's not going anywhere. In fact, a lot of people we work with Oracle people that become DBAs in the Cassandra world. But the companies that use Oracle, they're still using it, right? So if we're getting into data engineering from any angle, data science, data analytics, SQL is probably what you start with, and you're going to still need it for a long time. NoSQL. Now, there's lots of different, there's lots and lots and lots of different NoSQL databases. There's a reason why I kind of picked these. Mongo and Redis, they're very popular. They have been there for a long time. Not my favorites, but again, they are very simple. You just start up Mongo and you can just dump documents and retrieve documents, and it's pretty easy to use. Not easy to scale, but pretty easy to use. Redis, very, very functional in what it does for platforms that need a very quick cache to put data in and get data out. Lately, it can do clustered approaches. So Mongo is a document store, Redis is a key value store, Dynamo is another document store, although you can use any document store as a key value store. And then Cassandra under the hood is key value, column family, and now it has you can put documents in it using something like Stargate. There are other databases. Couchbase is another one. Bigtable is kind of the granddaddy of the distributed NoSQL, right? The Bigtable white paper was built on by Dynamo, and the Dynamo white paper was built on Cassandra. But the big thing in NoSQL is that it's all the same, but it's all different. It's NoSQL, meaning there's no necessarily any relationships between data, but you can create those relationships if you want to. But you have to know what you're looking for, or you have to know exactly what you're putting in it, right? The idea of querying a NoSQL database is an anti-pattern, unless you have an index that you've built on top of it. In big data, NoSQL is one of the different players, right? There's data lakes, then there's NoSQL databases. It doesn't mean that if you're doing big data, you're definitely using a NoSQL database. You could just be working with files, right? Speaking of data lakes, or HDFS, right? HDFS is a protocol that came out of the Google distributed file system paper that became the Hadoop file system. It's mimicked across different cloud systems like S3 or Azure Data Lake, and all of those big drives, basically cloud drives, they offer an HDFS compliant interface. That's because Spark uses the HDFS compliant interface out of the box. You can also get drivers for different things like S3 or Azure Data Lake. But it's a common standard at this point, right? And you can put any type of data in there. You could put key value as files. You could put JSON documents. You could put CSVs. You can put Parquet or Iceberg. It doesn't matter. It's a big drive. And so the common patterns, to learn are, are we using a cloud distributed file system like Azure, Google, or Amazon, right? And are we using the native protocol to access this information, or are we using the HDFS, the Universal Distributed File System Access Protocol? The reason I would say these are not going anywhere is because there's a lot of data on them now. Everybody has data on S3. Everybody has data on Azure Data Lake. So the protocols, they may change, but the actual systems, they're not going to go away. And I don't think HDFS is going away anytime soon either, just because in the open source world, unless something is absolutely unused, it tends to kind of stick around, right? So HDFS is used in Azure, in Spark, in Hadoop, in Presto or Trino, right? It can access HDFS drives. Streams and queues. If you're in an application world, these are not new to you, right? In application development, we use queues to move information, to notify people, but streams and queues are now also being used in data engineering. Why is that? Well, people want to take streams of information as they're being used in an application and update data stores rather than having to wait for them. RabbitMQ is very popular. There are now different databases that actually support RabbitMQ's, different queues that support RabbitMQ's protocol. Like, for example, I think Pulsar can mimic a RabbitMQ with a kind of a driver. Kafka is it's a distributed log, but it acts like a queue. Pulsar actually can support Kafka protocol as well. Lots of players are providing Kafka as a managed service, so Amazon is providing it as a managed service. SQS is different, and there's another thing in Amazon called Kinesis, which is similar to Kafka. But the point is that there's different types of queues. RabbitMQ and SQS are more about short messages coming in and then coming out, whereas Kafka can be used to put more data in there. And this is not the end all be all. There's lots of Azure has queues. Google PubSub Lite are basically synonymous with so Google PubSub more like SQS and Google PubSub Lite being more like Kafka, for example. And Amazon SQS being more like RabbitMQ, and Amazon Kinesis being more like Apache Kafka. So there's these two types of queues you're really looking at. There's distributed logs that can be partitioned and that can scale, and then there's other ones that are just first in, first out. It's one queue, one stream, and it gets backed up until you pull off all the messages. Whereas in a distributed log partition queue like Kafka, you can actually have multiple partitions for the same topic. You can backlog a bunch of data, but you can also read it very quickly. You don't have to wait until something is necessarily processed. Why is this important? To make a real-time data platform, you need queues. There's really no other way to go about it. The actual work. So last time I had on here, Stitch, data, and Fivetran, because I was kind of like bundling a bunch of different things. When I think about data engineering now, I'm really thinking about the code that one writes that is beyond the low-code systems, or that is to actually transform. So extraction could be happening somewhere else, loading could be happening somewhere else, but there's actually code that you have to write. And if you're doing data engineering, likely you're using Python or Scala or Java if you're in the JVM world. And one tool that I see all the time, not just in data engineering, this bucket here, but it would be in the other buckets of ETL, ELT, is DBT. And what DBT is doing is it's abstracting a bunch of the to and from and making it such that you write SQL and it takes whatever data comes in, it applies it using SQL, and then it sends it along its way, and it can run on top of Spark to be fast. So it's a good complement to Spark. So one may ask, well, why shouldn't we just use Spark SQL, or why shouldn't we just use the SQL that's built into the SQL database that we're using? And that's because DBT provides a standard. It's not just for Spark SQL. It's not just for relational databases. It could be used for other systems that are connected to DBT beyond an SQL database. And it just makes Spark SQL, I shouldn't say it makes Spark SQL a little bit easier to use. It just makes the process of transforming tons and tons of data, it makes it one standard. So no matter what comes in on one end and goes out the other, you're always doing it consistently with SQL, right? And DBT then figures out how to execute it. And you'll see DBT in a couple of different places. Orchestration, I used to call this data ops. However, data ops is more than just orchestration, it's everything. Airflow is probably the most commonly used one in data. Before Airflow, a lot of folks used to use Jenkins. Prefect is a competitor to Airflow, different, but I don't think necessarily it's going to replace it. And then Argo, which is, it's bigger than data. It does CI/CD for, it can be used, Argo workflow can be used for a bunch of stuff. But there's Argo, which is used to do CI/CD, and it's also can be used to do data flows. And actually the workflow engine is used by Kubeflow. So Kubeflow as a machine learning data pipeline management tool is built on top of Argo workflow. So Argo itself can be used for cool things in the Kubernetes world. Data warehouse. So data warehouse is different than a data lakehouse. They mimic databases, but they're not actually for transactions, right? A transactional database will have SQL. A data warehouse will have SQL. The difference is that the SQL running on a data warehouse has to potentially run across many, many computers. And its promise is not necessarily speed, it's accuracy. SQL Server and Oracle have their own data warehouse configurations. So those are still relevant. Redshift on Amazon, BigQuery on Google, Snowflake kind of across. On Azure, there's a few things coming out like Synapse, but different from the SQL Server warehousing tools. If you know one data warehouse in terms of a data warehouse design, except for a few nuances, you tend to know how to do it in other systems. Just like if you know how to design a table in SQL Server, you know how to design a table in MySQL or Postgres, or if you know how to design a table in Cassandra, you know how to design a table in Dynamo, actually, because there are no SQL systems. Doing data warehousing, design ETL with a data warehouse, they're similar, they're not the same. Things like Snowflake are, basically separating out this data layer and the execution layer, and even Redshift is starting to do that. And when we look at some other tools, a lot of tools basically copy this methodology of storing data in a distributed file system and then using a query layer to query it, even if it's not supposed to be like a data lake, right? So even data warehouses are kind of becoming like lake houses. The query layer, once you have your data in data warehouses or data lake houses or inside a database, there are some impressive query layers to allow you to query data from different systems. Sometimes people would say it's, it's a virtualization, but that's simplifying it, right? That's just simplifying it. Hive is a way to access data in HDFS with SQL. Then that Hive system became embedded in Spark SQL. So you can do SQL against different systems inside Spark. Trino and Presto, Trino being the newer fork of Presto. It can work independently and it can use Hive, but it can also talk to many, many different databases. And to scale, it can run on top of Spark. So why would somebody do Trino versus Spark? Because, well, Trino makes it one catalog. It takes all the databases you connected to it and makes it one big catalog of databases and tables, and you can do joins across different ones very, very easily. Right? Denodo is a commercial data virtualization tool, also can run on Spark. Very fascinating that all of these things eventually point to Spark. So Spark SQL is one aspect of it. Spark itself sometimes is just used as an execution engine. And so when I say Trino works on Spark, it works on top of the Spark execution engine. Denodo works on top of the Spark execution engine. Same thing with DBT. DBT runs on top of the Spark execution engine. I added a tool here, Dremio. We had a talk from a gentleman from the Dremio team talking about Apache Iceberg. And Dremio basically leverages a different data format than, let's say, Parquet. And I don't know where to put it. It could be technically a data lakehouse tool because there's a format, but it also is it's a query tool, right? But anyways, Dremio is another player to take a look at. BI tools, by the way, these have been around well before big data came around. People have made billions of dollars making the next big BI tool, which I look at them and they're pretty much same shit, different day. Excuse my language. They're all basically the same thing. Some of them claim to do more than others, but ultimately it's, I look at a BI tool, it's either old school, meaning it was doing everything for you. It gets your data, it helps you clean it, helps you visualize it. Or it started to be something you added onto your data warehouse. And then newer and cooler BI tools have like data profiling and things like that. But they're all the same. Ultimately, it's about visualizing data, creating dashboards, and sharing them with people. Tableau, Looker, very, very popular tools. Redash and Metabase are open source and also popular. I'm missing one on here. It's called Superset, Apache Superset. So one of the other categories I'm going to show that those tools are starting to, at least one tool is using Superset as an embedded BI tool. What do you have to know in BI? Most of them use SQL. You point to a data source, you get it added to your BI catalog. You can do joins, views on different things to show something impressive. A BI tool is only as good as the data that you've prepared. If you have really bad design in your data warehouse, it's not going to work that well. Your queries are going to be worse. They're going to be slower. So BI is like an application talking to a database that you designed in your data warehousing process. So if you are good at SQL design, then you're going to be pretty decent at least understanding what to look for, what to query. And then there's an artistic side of BI, which is which visualization should I use, which color should I use? And I think a lot of data analysts, they like this a lot. I used to love playing around with BI tools. I don't anymore. They're all the same. I got bored. DevOps, infrastructure, software, configuration, large-scale admin. So DevOps, I think, is and very rightly so, is sometimes it's misunderstood because it has a lot of things contained in it. And to make this talk simple, I didn't go deeper. You could go deep into DevOps and have different categories, but I put them all into one. In terms of data engineering, you likely are not going to be doing these things. You're going to be working with people that are doing them. But if you have understanding of what they are, you'll be better informed. Most infrastructures, they get created using infrastructure as code rather than somebody clicking and pointing, right? Nobody does that anymore, right? If they're doing that, you should tell them to use something like Terraform. Terraform abstracts it. Terraform is one way to abstract it. There's another one that came out of Amazon called CDK, Cloud Development Toolkit, or Cloud Development Kit, I think. And it actually works with Terraform, and I think it has providers for Azure and Google as well. But it generates code against Google or Azure or AWS. I'm not 100% bought off on it, but Terraform for sure. Terraform is kind of the lingua franca of all clouds, all hardware provisioning. Like I would look at Terraform first. There's even an abstraction to the three clouds, Azure, Google, and AWS, called multi, M-U-L-T-Y, where you say, I want a computer on Google, it'll make a computer on Google. You say, I want a computer on AWS, it'll make a computer on AWS. Prometheus and Grafana, just to note, are not just for monitoring systems. You can use Prometheus and Grafana for actually visualizing data if you have it in the right place. Prometheus is more of a collecting information and a time series database. Grafana is a general visualization tool. And I should probably add, Kibana can also be used as a BI tool if you, in the last category. Ansible, it's more than just configuring machines. Ansible could be used to have a step-by-step process outlined in code that is consistently executed. Now, why would you use Ansible and not something like Jenkins or Argo, right? Or even put it all in a Docker container? Because Ansible works best when it's talking to multiple things outside of itself to do a command. So it could be a list of 10 computers. It could be a list of 10 containers, or it could be a list of 10 Kubernetes clusters, right? It's just really good at doing the same exact thing across many, many systems and keeping track of it. That's where Ansible is so powerful. It's not something you don't use when you start using one of these other tools. It's just you can use it to be more powerful. And then finally, the new addition to the toolkit is ETL, reverse ETL, specifically low code and no code data pipelines. Because you can do ETL and reverse ETL with your own code. So why even add it as a separate category? Well, there are and there have been a lot of different ETL and reverse ETL tools. Well, I would say mostly ETL tools. Now, reverse ETL is a new category. ETL being extraction, transformation, and load or translation. There, you also have tools that do just ELT, extraction, load, and then transformation. But ETL or ELT tools are really about getting data from source systems that you don't necessarily have database access to, right? Although they can also do that. They standardize the extraction and load to some place like a data lake or a database, or they can standardize the extraction and transformation and load. Airbyte is fairly new compared to like Stitch data, but it's popular now because it's open source and it was just funded recently. Stitch is around. Stitch uses something called a Singer ETL framework, which is open source, and that means that you can use a Singer framework without using Stitch data. And then there's a tool called Meltano that is basically like Airbyte, has a lot of connectors, but it actually leverages the Singer framework to a certain degree. All of them have value. All of them are worth a look. On the reverse ETL side, there are many players. And if you look at my logo, you think, why are there more reverse ETL? There's a lot more ETL tools than there are reverse ETL tools. I can tell you that. I just didn't want to go down the rabbit hole of like telling you about every ETL tool. I mean, everybody and their mother is competing for making the best ETL tool, right? Or making the best reverse ETL tool. What I'm showing are the ones that I feel have some staying power. So on the reverse ETL side, Grouperoo, I think has staying power because it was bought by Airbyte, and both of them together are open source. And I think that's going to continue their momentum. RudderStack, I have known for a while as a CDP for developers, again, focusing on the customer data. I'm not sure it can do more, but because I've seen it for a while and it now is getting clumped into the reverse ETL stack, I feel like it's going to stick around for a little while. It has some good customers. And then there's relatively new players, Rivery, Census, High Touch, bunch of other ones out there. They're all competing for the same ground. Some of them claim to do ETL and reverse ETL. These RudderStack, Rivery, Census, and High Touch, they're all commercial tools. They're all as a service. And they're, well, money is a relative thing. To use any of these, like, to have any kind of impact, you're spending at least $1,000 a month, at the very least, to start, right? For like 5 streams, you pay $1,000 a month. So if you think about it, all the work involved to get data in and then send data back out, all the engineering, that's actually pretty cheap, right? But what if you don't have $1,000 a month and you want to just play around with stuff? Well, that's where I would say look at Airbyte and Grouparoo. Even Airbyte has, if you go to their catalog of connectors, sources and destinations, right? Any questions that are on the chat? If not, we can move forward. Actually, before we do questions, I want to say, if you want this cool t-shirt, Architect, we have a few of them hanging out. Please drop a comment and fill out a form on our website to contact us, and just say you're looking to get a t-shirt. All right, and we'll have a chat and see if you're an architect. Okay, back to questions.
Yeah, there's a comment from the YouTube chat from Ann Vroom. Feds use Tableau extensively, but generally I find their elaborate online customer-facing visualizations are either incomprehensible in terms of design or broken in one way or another.
Yeah, I'm trying not to comment on the BI tools, because I have not been playing around with them, working with them as much these days. But I remember, this dates me a little bit, but things like MicroStrategy and Cognos were the big player, and then after that, SQL Server reporting services kind of became a big deal. This is well before like the SaaS systems out there, like Domo was another one. But when Tableau came out and they started giving out free accounts to users in the academic community, I knew then that they were going to become popular, because they were giving it out to people and people were using it in school. They were creating visualizations for their school portfolios, right? That's why you have a lot of people that know Tableau, because it was just easily accessible for everybody. It's not the same with Looker. It's not the same necessarily, or it's not as is apparent that you can go get licenses to learn as it is with Tableau as a community tool. But yeah, thank you. Appreciate the comment. Anything else?
Yep, doesn't look like there's any more questions. We'll go ahead and wrap up here for today. We covered a lot of tools. So if you're interested in having a more specific deep dive on one of the tools, feel free to drop a comment on the video itself so we can get back to it at a later time and we can add it to our backlog. I have a couple things that I actually might take a look at, do a crack on a DEL. I think one of the reverse tools, Grouparoo, might take a look into it. I did something with Airbyte. You can check out the video. It's on our channel, as well as the Data Engineers Lunch playlist. And with that, we'll go ahead and wrap up for today. We'll see everyone next week. Don't forget to like, subscribe, and turn on the notification bell. And everyone, have a good day. Take care.
Thank you.